Hey guys, today we'll be working on the 2005 AMC10B Problem 22. For how many positive integers n less than or equal to 24 is n factorial evenly divisible by 1 plus 2 plus ... plus n? Well, let's see. If we want n factorial to be divisible by 1 plus 2 plus all the way to n, we know we want this to divide. Well, we know 1 plus 2 all the way to n, if that's just taking the sum of the first n positive integers. So that would be n times n plus 1 over 2. So from this, we want that n factorial over this value is going to be an integer. This is going to be some integer that we don't know. So we want to know what values of n less than or equal to 24 will make this an integer. Let's simplify this equation a bit. Let's multiply by 2 on both top and bottom. So we're going to have something like 2n factorial over n times n plus 1 is equal to an integer. Well, we also know let's simplify the bottom a little bit even more. What if we divide both top and bottom by n? Well, if we want to divide both top and bottom by n, we know n factorial divided by n. N factorial is like n times n minus 1 times n minus 2. So if we divide by n, it'll just be n minus 1 factorial, because it'll be n minus 1 multiplied by n minus 2 all the way down to 1. So this will just be n minus 1 factorial all over n plus 1. And this is equal to some integer. Well, in order for this to be an integer, well, we know if n plus 1 was even, it would work because we have a 2 on top, so it would divide evenly. But what if n plus 1 was odd? Well, we know n minus 1 factorial would always fit in because, of course, n minus 1 is less than n plus 1. So we want to find what doesn't work. So it wouldn't work if n plus 1 was an odd prime, because then it wouldn't go in evenly and it would not be divisible. So what are the cases that n plus 1 is an odd prime? Well, let's just list out all the odd primes under 24. We have 3, 5, 7, 11, 13, 17, 19, and 23. So here we have 1, 2, 3, 4, 5, 6, 7, 8 values for n plus 1. Of course, the real value of n would be 22, 18, 16, ... for those. So we know 8 values of n would not work. And how many total values can we consider? Well, we know we are considering anything less than or equal to 24. So that would be 24 minus 8, which is 16. So which leads us to answer choice C.